Hello, my name is Amos Tarfa, and I'm the director of the Learning Institute for Excellence and Life STEM Academy. In this video, I'm going to talk briefly about the first video in our series, From Counting to Calculus. We're going to learn all the math topics that are taught from basic kindergarten all the way to calculus. I hope you join me in this journey, but let's get started in the beginning here. Before I go into detail of the first video, this is our first video in the series, I want to give you a little background. See, I went to school in Nigeria. I grew up in Nigeria, came to the United States for my undergraduate degree. I got my degree in chemistry and philosophy. My minor was in philosophy. But during my years in my undergraduate degree, since then, I've gone on to get a master's and so on. But during my years in undergraduate time, though, I got to tutor at a math lab where I was helping kids with math. And I appreciate and I'm grateful for everyone who gave me the opportunity to teach back then. But while I was helping people, I found a book called Journey Through Genius, which talks about some of the history of mathematics. And I became fascinated with the story of Isaac Newton. And I realized that he was an ordinary guy who worked hard and made the most of the opportunities he was given. And so I graduated in 2010. I've been teaching math in different capacities. Even prior to that, I was teaching math as a tutor. But what's interesting, though, is I began to realize as I worked through the American math curriculum, when I was a full-time teacher for 2 years, I realized, wait a second, there's a lot of duplication in this curriculum. What if we could remove the duplication and help people just get stuff done efficiently and effectively? And all of that has led to this course that I'm about to tell you about. Everything before calculus, there's some work to be done. Let's just say that. There's a lot of work to be done. But anyways, we have too much duplication. We have a lot of kids who don't like math. America is not one of the best countries in math when they look at many standards. We look at the performance of many students in many districts, and sometimes 50% of them are failing algebra. And I said, you know what, something's got to change. And that's what I'm trying to do by God's grace. We have to change that. And here's what we're going to do. We're going to we have created a course that takes you through everything. But what I'm going to do is I'm going to present sort of a free series of some of the lectures here. If you want more of the specifics and the mechanics of math, you can sign up for the course called Counting to Calculus. If you need a discount code for that, let me know. But right now, the course is available for anyone who wants to sign up. You can also sign up for my individual courses on pre-algebra, algebra 1, and so on. But here's what I want to explain in this video to get us started. Sorry, this has been a long introduction, but we're really going to be, like, imagine you're getting in a tour bus, and we're going to take a tour of mathematics. Like, let's go. We're going to go all around the world and all around civilizations and learn the history of mathematics. So, where do we begin? As I said, everything before calculus, right? This is calculus. Everything before calculus is generally needs a lot of work. Once you get to calculus, though, when you tell me you've taken calculus 1, for the most part, I know what you mean, and I know what topics you've learned. But if you tell me you've taken algebra 2, I need to ask you, where did you take it? What school? What textbook? What concepts? Like, that's not as clear as calculus is when we talk about curriculum. So that's why my course stops right before calculus. That's one of the reasons. I think that we can do a deeper dive and talk about calculus, but we don't need to do that right now. What we need to do is help as many kids as possible to love mathematics. Mathematics is about patterns, and I'll actually show you one quick example here before we dive into our first topic, which is counting, calendars, and clocks, right? That's like the very beginning in terms of the applicability of mathematics. Counting, calendars, and clocks. Before we dive into that, as I said, math is about patterns. So if somebody said 2, 4, 6, 8, right? You say, oh, the next thing is 10, right? These are even numbers. See, with math, you're dealing with patterns. You're finding patterns, and you're making models to explain those patterns, right? One of the greatest mathematicians of all time, Leonhard Euler, in his book, Elements of Algebra, tells us, so this is Elements of Algebra, free, you can find it online. And in his book, he tells us also what mathematics is. He says, whatever is capable of increase or diminution is called quantity or magnitude. Whatever is capable of increase or diminution is called quantity or magnitude. A sum of money, therefore, is a quantity, since we may increase it or diminish it. It is the same with the weight and other things of this nature. From this definition, it is evident that the different kinds of magnitude must be so various as to render it difficult to enumerate them. And this is the origin of the different branches of mathematics, each being employed on a particular kind of magnitude. Mathematics in general is the science of quantity, or the science which investigates the means of measuring quantity. They're means of measuring quantity. That's one way to think about mathematics. Now, mathematics has different branches. We talk about arithmetic, we talk about algebra, we talk about trigonometry, geometry, calculus, number theory, discrete mathematics, abstract mathematics. But in this course, we're really dealing with arithmetic, algebra, trigonometry, and geometry. That's a lot of what we're dealing with in this course. So I'll be teaching you strategies to do well in math, as well as the concepts that you should learn. Okay, so we're talking about the beginning of mathematics. Part of the beginning of mathematics goes to counting, and I'll give you some of the foundation for where we're going with this. So there's two resources here. One of them is called The World of Mathematics by John Hudson Tyner. And in this book, he does provide the details of some of the history of mathematics. Very cool. A lot of people are discussed. He does have a book on astronomy as well, which is actually interesting because astronomy is like they were the first scientists, quote unquote. Astronomy is part of what gave rise to physics, which gave rise to some things in chemistry. And it's all fascinating to learn that history. I have a course that I'm going to be working on this fall on the history of science, so you can stay tuned for that. But in my hand here, I have the third section of a book that I wrote called Tools for Mastering Mathematics. And this section goes over all the topics we teach from kindergarten to calculus. So this document has all the topics we teach. I used over 25 textbooks to compile the list because I didn't want anybody to say, well, Amos, we use this textbook in my district, so you probably didn't cover this topic. Well, actually, we grabbed all the topics we could get from every textbook. I'm putting 25 as a low end. It's more like 50 textbooks of different kinds that we've used through the years to gather all the data into one document. And the very first topic in our journey is counting, calendars, and clocks. So let's talk about that briefly, and then we'll let our plane land. And then next time, we'll talk about other aspects of arithmetic. So let's talk about this right here. What is this about? Well, I'll just tell you a little bit of my journey of why I'm doing it this way. So this is K-12, right? So there's about 13 years. I actually think if you're in America and you have a vision and you know where you're headed, you can complete the K-12 education in 7 years without sweating. If you want to sweat, we can do it in less. But I would say that by the time you get around here, right? And this is assuming that you're using your summers to learn, okay? This is assuming you're using your summers to learn, because there is literally about 39 months of summer months that people can use for their education. I don't know why we need to take the whole summer off. It's not like everybody is farming and so on. Most people are not doing that. So why don't you spend the summer just learning for fun, but tie it to your education? So we have K-12, which is currently 13 years, and I think we could cut it to 7. Oh, you might say maybe 8, Amos. Take it easy. Okay, sure, we could do it in 8 years. You do your K1 with your summer, make the most of it. By the time you get to 2-4 here, 2 to 4 here, again with the summers, you can really do some work to condense that, get some work done. In Nigeria, you could actually skip 6th grade. So some of the Nigerians you've met in America didn't do 6th grade, right? I didn't do 6th grade. You don't have to do 6th grade. If you test well enough, you're allowed to actually skip it altogether. That says something. There's a lot of similarities here, especially in the Nigerian curriculum, but even in the American curriculum, there are some textbooks you could just combine rather than doing one. So now, I understand this will work more for a homeschool setting, but I'm just telling you that you could really condense things. Now, why am I trying to condense things here? Okay, take time to learn what you need to learn. That's great. But if you've learned what you need to learn, keep moving. And if you keep moving, my point is you probably wouldn't take 13 years to do a K-12 education. No way. There's just no reason for that. If you are using deliberate practice to learn. There's a book by the man Anders Ericsson called Peak. And in that book, he talks about, so his name is Anders Ericsson, and the name of the book is Peak. In that book, he talks about deliberate practice. He's the guy who people quote as saying the 10,000-hour rule. I know Malcolm Gladwell wrote about the 10,000-hour rule, but Anders Ericsson is actually the guy who came up with the rule. So Anders Ericsson, he came up with the rule with saying 10,000 hours of deliberate practice will get you, high levels of mastery, high levels of performance. And so when you read a book like that, you realize if you're using deliberate practice and you're using your summers wisely, you can cut down time to focus more on figuring out why you're on this earth so you can be a blessing to people with the time you have rather than doing busy work and wasting the life you've been given. That's where I'm coming from when I'm trying to be more efficient, because we only have one life to live. People like John Dalton, my friends, were teaching at the age of 12. John Dalton, Dalton's laws of partial pressures, you might have heard of him. He was a principal of a school at the age of 18. Like, these guys didn't have Wikipedia. They didn't have Google. And they were doing, I could go on and on with these people. A lot of them were graduating like upper level stuff at the age of 15 without the internet. Why can't we be efficient like them? See, they were passionate about learning. We need to encourage people to be passionate about learning because we've been given one life to live. Let's learn to the best of our ability and let's use what we've learned to bless people. Whatever it might be, whatever your skills are, realize that you're not too young to be seeking to flourish, okay? Okay, back on task here. So math is about patterns. The book Peak is one of the books that is going to govern how we teach this course, and it teaches about deliberate practice. Imagine if you did your K-12 education in about 7 to 8 years, and then imagine if you, while doing that, you actually clept all your generals or took all your general courses, and then you do 2 to 3 years of your 4-year degree. You can cut down a K-12 education and a university education from 17 years to about 9 years. And you could technically say, let's say, sure, let's make it 10 or 11. We can have people graduating college at 18 as the norm. Like, you're graduating college as 18. I'm not saying you're graduating high school. No, you're graduating college at 18 or 19. Some people might be concerned, Amos, what about maturity? And that's where we encourage people. It's not all about knowledge. It's also about seeking wisdom, which can be found in God's word, right? When you're reading the Bible, when you're praying, when you're spending time in community, when you're being a blessing to people, you will mature. People will look at you and say, how old are you? I'm 19. And they say, stop lying. You're 27, right? Because they've noticed that you're seeking wisdom. My friends, we need a new paradigm. We can't continue the way we're going, especially because of the technology available to us. If Leonard Euler and his friends and some of these people who were not prodigies were getting done with college as 18 without the internet, why are we getting done at 22 and still clueless about the future? We need to rethink what we're doing with the lives that God has blessed us with. And please, this is not to make you feel bad if you're in your 20s and you're trying to figure out life. What I'm saying is we need to pause. Enough of the running without vision. And we need to ask, what is the point? Where am I headed? Who's my coach? Who's my mentor that can help me to get to where I need to go? Okay, I know I turned this into a side lecture, but I thought it's important that I show that we can be more efficient in our education. So, mathematics was heavily focused on teaching. Back then, let's talk about Abraham's time, for example. We talk about Abraham, Isaac, Jacob. A lot of math back then was counting. How many sheep, how many goats, how many cattle did this person have? That's where we're doing the counting. So math initially, a lot of it was heavy on the counting side. So in our journey from counting to calculus, the first piece is counting. And of course, we start from the number 1 to 10. We call those natural numbers. Why don't we actually talk about the types of numbers before we let our plane land? And then we'll go from there. So let's quickly talk about natural numbers, okay? So natural numbers are numbers like 1, 2, 3. And those are the numbers that we use when we're dealing with like age, right? Those are called natural numbers. Okay, the next thing we're going to talk about is whole numbers. So this was a diagram I saw in one of the textbooks I looked at back in the day when I was teaching. And what they did was they put another circle, right? This type of idea is called, we could call it a subdivision of set, using sets. So this is a set, all the natural numbers from 1 to infinity, okay? Call those natural numbers. The next level is whole numbers. Okay, whole numbers is where you go from 0, 1, 2, 3. But notice that all natural numbers are contained in whole numbers. Then the next category above that is called, so we have integers. Integers include negative numbers, right? So you come from negative infinity and you include negative numbers. Okay, so we have natural numbers, we have whole numbers, we have integers, right? So these are the categories of numbers that we deal with. Now, back in the day, a lot of the work was you're dealing with natural numbers, some whole numbers, not so much integers, right? Eventually then, of course, that happened. But then we have another category here, which actually came pretty quick. Rational numbers. Now, rational numbers are, if you can take any number and write it as a fraction, like 1 over 2, or 3 over 4, or 2 over 1, which is 2, of course, or negative 3 over 1, which is negative 3. If you could do that, that is technically called just a rational number, right? When you think of fractions and you're working with fractions, a lot of them will be called like rational numbers. Now, I'm going to put all of this in a box. And when we put this in a box, there's actually another division over here called irrational numbers, okay? Irrational numbers are a little tricky. So in our box, both rational and irrational numbers belong. So this is irrational numbers. Irrational numbers will be things like pi, things like e, things like the square root of a prime number. Those are irrational, right? When you do pi, it's going to go on and on and on, but it's not necessarily repeating with a certain pattern. You could do 1/3 here. We know it's 0.333 repeating, but over with irrational numbers, you have 3.14, and then it starts, it just goes on and on. Now, if you have friends who are trying to make you feel bad for not knowing pi to many digits, tell them that there are people who have memorized pi to over 5,000 digits, and tell them to try telling you pi to 5,000 digits. Now, I haven't memorized pi to 5,000 digits, right? My wife and I have 6 kids. I'm busy. I don't think I have time to be memorizing pi. But maybe if you want to do it, I would say maybe do something else. Go help your neighbor. I don't know, sweep their yard, do something. Memorizing pi to more than 5 digits, I think it's just fine. Now, if that's your hobby, I'm not going to stop you. I'm just saying we don't need to know it beyond a certain set of digits. Anyways, now some people just call pi 22/7 also, but it is an irrational number, okay? So irrational is a category. So we have natural numbers, whole numbers, integers, rational numbers, irrational numbers. All of these actually belong in a category called real numbers. So real numbers they contain both rational and irrational, right? Sorry, let's write that out well. Real numbers, okay? These are the different types of numbers. Now, counting, again, back then, a lot of things we're dealing with are your natural numbers and whole numbers. You're dealing with mathematics with its use in agriculture. You're dealing with mathematics on that level. There's also discussions, of course, about, as I said, astronomy, dealing with the solar system, dealing with just observing the natural world. So that's where we're starting our journey. And for time frame, let's just zoom in our time at about 2000 BC, okay? The Egyptians, actually, when we talk about fractions, some of that is tied back to the Egyptian civilization, one of the greatest civilizations. And the book of Genesis in the Bible talks about the Egyptians, and the end of it talks about Joseph going to Egypt, and then in Exodus it goes into more detail. But the Egyptians, we talk about fractions, and some of that coming from the Egyptian civilization. So we're going to start our journey about 2000 BC. We're going to look at a timeline of mathematical events, and then we're also going to look at just a progression of discovery of like what we know or have what we did with math, right? Where did we get the 360-degree idea? Where did we get the 60 seconds in a minute? Where did we get the calendar? These are some of the things we'll be discussing in this course. In this first video, I just wanted you to understand part of my vision and my heart and passion for mathematics and knowledge and truth. And now I want us to step into more topics. Again, we've introduced numbers. We've introduced a little bit of, again, calendars and clocks. We'll dive into that a little more later. And then we'll talk about place value. That will be one of the next main topics. My book, Tools for Mastering Mathematics, is available for free on my website. I have a personal website, livingsensibly.org. You can find the books there for free. But if you want to take this course or any other courses, feel free to sign up using the course link in the description, or just send me an email. I'll be happy to send you the course. I hope this has been helpful as we start our journey of changing our mindsets and realizing what we're capable of with the resources we have. And I hope we enjoy this journey as we go all the way to calculus. Thank you for watching. Feel free to subscribe and pass this on to others who would enjoy this video, and have a blessed day.